that it just doesn't. Okay, there we go. All right. Going live, which probably means we're already live, but I do not know. Hello. We are now officially live. Hello, everyone, and welcome to the Gravity Max live stream. So today, we are doing the game show stream. We're an hour behind, but that is a-okay, because is time even real?
Very interesting.
I don't think it is.
Very, very
No.
interesting.
Yeah.
Speaking of interesting, you'll note that our cameras are in very interesting spots on the screen, and you will see why
Yes.
on
Yes.
the coming slides.
It's like that old game show thing on like TV that was like called Hole in the Wall, right?
Yeah.
Where you would have the wall like a weird shape.
Yeah, I remember that.
But yeah, no, this is just pretend, right? We're not an hour late. We're just broadcasting from an alternate universe in which daylight savings does not exist.
Yes.
So
We're
I think,
like squatters in a city. We're
yeah,
like, we
I don't
will
know.
not go. We will not go.
Yup. Yup. All right. So yeah, I guess let's just get started.
Welcome.
Plugs.
Oh, right. Oh, and they can see
Right.
the
Yeah.
boxes. The boxes
They
that
can
we
see the
usually
boxes.
have
Uh-oh.
our
Uh-oh.
cameras.
They can, behind the veil, they can see.
They know.
All right. Visit the Gravity Max website at gravitymaxmedia.com. Follow Gravity Max on social media. If you follow us on social media, then you can get updates like today's update where I said that we're going to be an hour late. If you don't check out the social media, then you might miss stuff like that. So make sure to do that.
Like squat.
Also follow Sebastian on social media, 128 seconds on Instagram and on YouTube. He makes quick educational videos every other week, and they are very high quality and very informative.
Thank you.
Very interesting.
We also have some chat.
Oh yes, we have Darren Wang says, "Cool stream." Thank you,
Darren Wang.
I do not know who that is.
I know.
Okay. All right. So then, check out Govern Max on YouTube. I've kind of been slacking.
Let's talk about slacking. I haven't been showing any of these slides.
Oh yeah.
This is my channel, 128 seconds short videos. This is Max's other channel, Govern Max, government videos.
Mm-hmm. So I don't know. I was supposed to do a stream on Friday, but I was still kind of like, I'd been sort of wiped out the whole last week. I might, I don't know. You can check it out for stuff about January and February, but I'm not sure because school is getting pretty.
That makes it good for projects because projects are usually like what's happened in the past couple of months. Like when I was taking even current issues, even though it was a current issues class, it was like stuff that had happened 1 to 2 months ago. So
yeah. So this will be sort of more on and off. I apologize. Then a somewhat odd start coming to Amazon, April 23rd, or a few days after. Sometime that weekend. Third book, sequel to the first two, so go check those out.
Make sure
Space Game Show.
Make sure you get it. Space Game Show.
Yeah.
Space Game Show.
Space Game Show. The showdown of the Giga Anim.
Yes. Oh, here, I will skip to that slide. Showdown of the Giga Anim, baby.
Look at it. Okay.
I'm gonna have to be going in and out of present mode as we usually do.
Yep.
But let's get into our categories for today.
All right. The categories are physics, true or false, space habitats, astrography, which is like geography but in space, technology, so space technology, multiple choice, and so Sebastian has a section I like to call Chicago or Io, where it's actually more accurately Chicago, Io, both or neither. So I'm going to ask him questions, and the answers are all going to be Chicago, Io, both or neither. So we shall find out how similar Io truly is to Chicago. And then Sebastian, or I have questions about Alpha Centauri that I have to answer because I forget when, but a while ago, I laid claim to the Alpha Centauri system.
Max has staked a real estate claim on it. So I
need to properly survey my property.
Of doing the real estate legwork.
Yep.
You may also notice that there are some recurring guests on screen.
Oh, yes.
And those will be our game element for today.
Yeah. The doppelgangers.
The doppelgangers. It's unknown where they came from. They showed up one day on the second episode of this season, and they've just kind of been there. But this is Gravity Min, the inverse of Gravity Max. And this is 49 seconds. Whose color scheme is haunting, to say the least.
Yep. Agreed.
So guess what's funny, Max? Guess what's funny? I forgot to make the physics questions true or false, so I'm just gonna I have to turn them into true or false questions real quick.
It's fine.
I mean, I should be able to, but if you get one that I just haven't figured out how to make it true or false, don't hold it against me. No problem.
I will not hold it against you. So yeah.
All right. I forgot who got the first choice last game.
Do you have a coin? Do you want to flip a coin?
I do have a coin.
All right.
Who stole all my coins? Nothing but coins on my desk.
Who stole all my coins? The elves.
Honestly. And my dice. I've just been robbed, man. Oh, here we go.
I've been robbed. Oh, no.
Alright, six-sided die. Do you want odds or evens?
I'll take odds.
Alright, you'll take odds. I got evens. 6.
So you get to go first.
Yes. So, I will take... as this currently is a multiple choice, I think I'll go with Astrography for 200.
Astrography for 200. Okie dokie. I'm just going to put the square. There we go. Okay. How long does it take light to get from the surface of the sun to the Earth?
I'm going to say about... Oh, wait, it's... Oh, yeah, I didn't actually choose multiple choice, right? I'm going to say about 8 minutes.
Correct. 8 minutes and 20 seconds. So,
again,
nice
I'm
job.
Going in and out of percent mode.
Oh, yeah, no problem.
Or, I could just keep us here. Because that's not too... Oh, wait, I learned that other trick where I just, zoom it in.
Oh,
yeah, that kind of works. Yeah, look at that.
Yeah, I've relinquished my dream manager position because it is not fun.
Yeah, but now I can make us bigger, which is good. On stream editing, everyone.
Oh yeah.
Give it up.
Oh yeah.
There we go.
I'm glad, the real reason that you're doing the streaming is because you have the better computer, but I don't bemoan that fact. If you know what I mean.
Yeah, I think I'm actually going to move us down here just so that you can see whose game board it is, because I was covering our names.
Okay. Makes sense.
And there we go.
All right. So, now it's my turn.
Yes.
I will pick habitats for 200.
God, the OBS is spazzing. All right, habitats for 200. Let me pop over to yours. All right, Max.
Yes.
Does this change the zoom? Yes, it does. Damn it. Because my answers and questions are also a Google Doc. It uses the same zoom. That is incredibly annoying. And so I will be reading off my phone now, I guess. But for this one,
all right.
Habitats for 200. Also a question about the sun.
Nice.
How many minutes does it take to watch the sun rise and set if you are on the ISS?
Okay.
I'll give a tolerance of a couple of minutes.
Okay, rise and set once, then you only need to do half an orbit, so that's 45 minutes.
That is correct.
Nice. All right.
So let me get the zoom back in order. I apologize.
Yes. It's all right.
There we go.
That's the fun of the Crafty Max live stream.
So that is $200 for us both.
Oh, yeah. Yes. Showdown of the Giga Atom.
Of the Giga Atom. All right. Just real quick, I'm going to pull
up
my stuff on my phone.
Cool.
All right, and we were good to go.
All right.
I will take...
So what's your next? Yeah.
I will take physics. True or false? For 200.
All right. Oh. Oops. Okay, there we go. All right. Physics, true or false for 200. Okay. True or false? 1 Newton is equivalent to kilogram times meters divided by seconds squared. So
kilogram, say it again?
Yeah, so it's kilograms times meters divided by seconds squared. True or false, is that equivalent to the unit of Newton?
All right, so Newton is a measure of force. So think about it. It's interesting that there is, like, the second squared sounds right, but just, like, taking it on paper, it seems a little weird that there's a time aspect in force, although that could just be a tie back to work, which does have a time element. So going on the basis of that, it could be related to work. I'm gonna say yes, that's true.
Correct. It is true. 1 Newton. The way that I always remember it is F equals ma.
Right.
So acceleration is meters per second squared, and mass is kilograms.
Yep.
So if you multiply them together to get force, then you multiply the units together to get kilogram meters per second squared.
Very nice.
So, yeah.
Very nice.
All right. Next, I will pick technology.
Technology for 200.
Yep. Technology.
All right, and I'm reading off my phone now.
All right.
In which stage of the Kardashev scale does a post-scarcity civilization become a possibility? The first stage in which it becomes a possibility.
I would say stage 2.
That is correct. Kardashev
All right.
2.
Nice.
Very nice. All right. We are in a current flawless match.
Nice.
Something tells me it will not remain that way.
Yeah. Maybe not.
I am gonna go for. I want to see what you've done for this. Let's see Chicago.
All right.
200.
Chicago.
By the way, if you paid me $200, I would not go to Chicago.
Oh, that's an interesting bonus fact for the audience.
Yeah.
Okay. Chicago, Io, both or neither.
Mm-hmm.
Is negative 57 degrees Fahrenheit a temperature from Chicago, Io, both or neither?
Oh, shit.
Negative 57 Fahrenheit.
It's definitely possible for Io. This is not my answer, but it's definitely possible for Io. Io does not have an atmosphere. Io is just floating next to Jupiter. And Jupiter is pretty far away from the sun to begin with. So I'm going to say that is definitely a temperature that has hit. And Chicago, I remember it had that super deep freeze a year ago? Question mark, a year or two ago. Although, did it get down to 57 Fahrenheit? Or negative 57 Fahrenheit? Is that what you said?
Yeah, that's the question.
Negative 57 Fahrenheit. That is... That's pretty cold. Now I'm trying to think, what is the coldest temperature ever? Which I don't know. And you know what? Chicago is cold. It's nasty. I'm going to say that is a temperature from both.
It's actually a temperature from neither.
From neither?
Yeah. So this is sort of difficult. The Io one, some people count the volcanoes, but we don't do that on Earth when we talk about record temperatures,
never
right?
Gotten as hot as negative 57 Fahrenheit.
Yeah, exactly. Io has a maximum temperature, excluding the volcanoes, of negative 225 degrees Fahrenheit.
Right.
Which is really cold. With the volcanoes, it's up to like 3,000 degrees Fahrenheit, but I think that's kind of stupid.
No, it's surface
right.
temperature.
Okay. So yeah.
And Chicago just hasn't hit that.
Chicago got down to negative 27 degrees Fahrenheit.
Yeah.
That's the record low in Chicago. And I think that's sort of like city effect, where cities tend to be hotter than their surrounding areas. But also, yeah, some parts of the Midwest, like last year, did actually get down to like the negative 50s.
Yeah.
But yeah, not Chicago. So yeah. First wrong answer. I apologize.
Whew.
I guess
that's a blow.
Yeah, it proves it. It proves the
if there was ever gonna be
Chicago inequivalence.
If there was ever gonna be a column to get me out, it'd be Chicago.
Yep.
All right, Max, your choice.
All right, I'll pick multiple choice for 200.
Multiple choice for 200. What is the SI unit for entropy? Is it joules over degree Celsius, joules over Kelvin, or entropy does not have an SI unit as it is instead measured in the number of microstates created in a closed system? I can read that again if you need.
I'm pretty sure it's the last one. It's the number of microstates in a closed system, so it doesn't have an SI unit. That's my answer.
Joule over Kelvin. It does have an SI unit.
I stand corrected.
However, microstates do play a really big role into it.
All right. Interesting.
And just like that, we are on equal terms. I'm also going to fix my hair because it isn't just not cooperating. This is what I do. I just hide my hair behind my headphones so nobody knows.
No one will ever know.
Nobody knows. There we go. All right. And we are back on equal footing. All right. I will take habitats for 200.
All right. Habitats for 200. Okay. The question is, what is the maximum permanent occupancy of the ISS?
Maximum permanent occupancy.
So I define permanent as more than 2 weeks.
I know there is usually 7. I don't know if that is the maximum. I remember like the number 9 is also floating around my head, but it would seem strange to me that there wouldn't be the maximum number of people in space at any given time. I'm going to say the maximum occupancy is 7.
Yes. So it's kind of weird. It's like 6 or 7, so I'd accept both. So you get it. So the reason it's 6 or 7 is that like it can technically sustain 7 people, but the number of escape vehicles they have is only enough for 6 people. So it's sort of like a Titanic thing where it's like they don't want to have 7 people on, right? But I'd include 7. So yeah.
Very nice.
There you go. All right.
Your
That's
choice.
Okay. Oh, let me fix this. Okay. I'll pick astrography for 200.
For 200. Which planet in our solar system has been predicted by experts to be the future epicenter of jazz music?
Venus.
That is correct.
Yes. The jazz capital.
It's the jazz capital of the solar system, man.
Nice.
Venusian jazz, you can't beat it.
You cannot beat it.
All right.
All right.
I am going to go for, because it has now become less of a multiple choice, I'll go for multiple choice.
All right. Multiple choice. Okay. Multiple choice. Which is the largest asteroid? Ceres, Juno, Pallas, or Vesta?
Ceres is... I thought Ceres was a dwarf planet. And I'm not sure if something...
All of these things are asteroids.
All of them are asteroids. Then, all right, the largest out of them. You said Ceres, Juno, Vespa, and... What's the other one?
I'll repeat. Yeah. Ceres, Juno, Pallas, and Vesta.
Pallas and Vespa. I'm going to go Ceres.
Nice. That is correct. Ceres is the largest asteroid, and it is also a dwarf planet. It's kind of weird. It's both. Mm-hmm. So every asteroid gets a number, right? And so it's technically it's called 1 Ceres, right? Then there's 3 Juno, 2 Pallas, and 4 Vesta, and that's just the order of discovery. Although it roughly maps to size when you get enough of them. But Vesta is actually the second largest. But yeah, anyway. All right, so that's another 200. Yeah. All right, now it's my turn. I will pick Alpha Centauri.
He is stepping into the field of real estate.
Yes. Free real estate.
The number one thing about real estate when you're looking for a property is location, location, location. So let's talk about the location of the property you, sir, are looking at.
Yes.
How far away is Alpha Centauri from public education, a city center, and a grocery store in sig fig light years?
Okay. Alpha Centauri is 4.24 light years away from all of those things: public education, a city center, and a grocery store.
I'm going to call that pretty close. I have 4.37 light years.
Okay.
I don't know if I just used the...
I think you used Alpha Centauri, and I said Proxima Centauri.
Yeah, so yeah, I should have used Proxima, so yeah.
Yeah, I guess I should have said Alpha, actually, because you did ask for Alpha, but...
It's all good.
It depends which part.
Yeah.
My kitchen is closer to the...
or something like that.
Yeah, my kitchen is closer to, the highway or whatever. Yeah. Right. All right, so yeah. All right, next question.
All right. And I believe we are still on equal footing.
Yep.
I would like to make everyone at home suffering from OCD very angry and go with physics, true or false.
Wonderful. Everyone is very pleased with the situation. Okay, physics, true or false? Where is it? It's at the beginning. Okay. True or false? It is possible to travel at 300,000 kilometers per second.
300,000 kilometers.
And let's say, sig figs, infinite sig figs, okay? This is specifically 300,000, exactly.
Is it possible for, me or for, light?
Is it possible for anything in the universe?
God, no. The speed of light is 3 × 10⁸. There's seconds, miles. There's 8. 3. Oh, but then it's kilometers, which would make it 9. So no, it's impossible.
Yeah, correct. So it is not possible to travel at 300,000 kilometers per second. You can only travel up to 299,792 kilometers per second.
Right. That's how I came to that answer. I knew exactly what. Yep.
Okay. You got it correct.
I got
it. Anyway, physics, true, false.
Physics.
That's my next choice.
True or false? All right, let's see it. Here, I'm also just going to boost our audio. All right, physics, true or false? Which, I got to swap over to you. Which, is not a true or false question.
That is perfectly fine.
I don't think it's that difficult, but here you go. On weekdays, I like to stay in my bed until my alarm goes off for the 3rd time. Until that, I'm not moving. What law of physics am I demonstrating?
Inertia.
Yes. And which of Newton's?
Oh, which of Newton's? That's the first law. A body at rest will stay at rest. Yeah.
That is correct.
All right. Your turn.
I am going to go for technology for 200.
Nice. Very good. All right. Technology for 200. Name a technology that was aided by the space race.
Any technology.
Any technology. Or, well, I guess I should... That wasn't specifically rocketry. Anything other than specifically rocketry.
I guess that was aided by the satellite technology, I guess.
Sure.
Is that because that's not specifically rocketry per se? I could also say nuclear chemistry. Or I mean, things involved within nuclear chemistry.
Sure. You got it.
I don't know, man.
Some other examples include the GPS and the water purifier.
There you go.
Yeah. All right. Bam. There you go. All right, now it's my turn. I will pick multiple choice for 400.
Multiple choice for 400, right?
Yeah.
All right, for 400. In the famous, I'm gonna mess up the first part of this, someone's last name, Haffel-Keating experiment, where atomic clocks were flown on commercial airliners to determine the effects of time dilation, what were the differences in time measured in? Picoseconds, nanoseconds, microseconds, or seconds?
Not seconds. Let's say nanoseconds.
That is correct.
Nice.
The differences on the atomic clocks were all measured in nanoseconds.
Nice. Yes, very small differences. All right. Bam. Oh, wait.
Very nice.
There we go. All right. What is your next topic?
I'm going to go for... Let's go for redemption. Chicago 400. Fun fact.
All right.
If you paid me $400 to go to Chicago, I would tell you keep your money.
Okay, so this thing, this whatever, was discovered slash founded in 1833. Is it Chicago, Io, both, or neither?
Oh, God. There's no way both happened on the same year. I am going to guess that it was one of them. That you said 1833?
Yep.
All right. I know that the 1830s were actually big with scientific discoveries. I think something else, maybe even in one of my questions, was discovered in that time period. I hope that's not an answer. But I'm going to say that Io was discovered in 1833.
Io was actually discovered in 1610.
Oh, it was right
and
with Jupiter.
Chicago was founded in 1833.
I'm never going to forget that. Awesome. People are going to be like...
Sebastian's favorite year of history, 1832.
Jesus.
All right.
Get the Chicago category. It's just going to kick the snot out of me. I hate this category. Why did we... All right, your turn.
Chicago. Yeah, okay, let's see. I'll go with habitats for 400.
Habitats for 400. Which exoplanetary megacity has the tourist attraction known as the Glasslands?
Oh, that is an O'Neill cylinder.
Yes, it was. Yes, yeah, all right, yeah, that's fair.
Oh, okay.
It was a callback to...
Oh, wait, Pallas Prime, right?
It was the Pallas Prime. It was the Pallas Prime guy and the what girl?
Pallas Prime guy and the something Angelus, like
the Neo Angelus girl. Yeah,
Neo Angelus.
Yeah, nice. But it did come out of our discussion about an O'Neill cylinder. So, yes.
Nice. The Glasslands.
Glasslands.
Yes. The Glasslands are very high quality. Very high quality teen movie, like angsty place.
Yeah, 100%. But it'd just be cool and terrifying to just look into the absolute void.
Yep. Yeah, even though it's an outdated design, it should still be built just for the sake of being cool. So yeah. All right, now it's your turn.
With astrography.
All right, astrography for 400. Which is closer to Earth, Venus or Mars?
All right. Let me think. Which is closer to Earth? I know which one's bigger than the other. I think Earth is still bigger than both. I mean, Venus is closer in size to the Earth. But I'm going to say Venus is closer.
Yep, right. That is correct. Venus is physically closer in terms of the fact that it can... A Hohmann transfer orbit will take you, like, I forget, it's like 6-ish months to get to Venus, but 9 months to get to Mars.
Right.
So, yeah. All right. Yeah. Okay. Now it's my turn. I will pick technology for 400.
Technology for 400. This one is also a Kardashev question.
All right.
If current trends continue, and based on estimates we talked about in the first part of our Kardashev video, how old will I be when we become a Kardashev 1 civilization, give or take 10 years?
Okay, I remember you saying it would be like 150 years. So you'd have to be like 150 plus 16, so 166.
I would actually be 95 years old.
Oh.
It is estimated that it was in 2100 AD is the estimated year in which we will be close or at a Kardashevian civilization.
All right. Nice.
So I could see it. I could see it if I get to 95.
Yeah, I think that'll be commonplace by the year 2100.
Yeah, I hope so.
All right. Yeah.
All right. I will take multiple choice for 400.
All right. Multiple choice for 400. Okay. How long is a day on Jupiter? 3 hours and 50 minutes, 9 hours and 50 minutes, 20 hours and 10 minutes, or 42 hours and 30 minutes?
Say the second option again.
9 hours and 50 minutes.
I'm going to say 9 hours and 50 minutes.
That is correct. A day on Jupiter is 9 hours and 50 minutes.
I remember that surprised me about how it spin was faster.
Nice. All right. That's my turn.
The scores are looking good. The balances are looking good.
Yeah. I will pick Alpha Centauri for 400.
Alpha Centauri for 400. All right. So when you're looking at real estate, you got to look at current trends. And currently, the average cost per square foot in the U.S. is about $123.
Okay.
Using this estimate, how much would buying solely Alpha Centauri A cost? And I gave you a multiple choice on this one, but you can also...
Wait, is it... Here, wait, just a question. Yeah. The star itself? Just...
The star itself.
Okay.
And you can also use your calculator if you want to start calculating things. So just real quick, again, the average cost per square foot is $123 per square foot. And using this estimate, how much will buying solely Alpha Centauri A cost? And I did it based on surface area.
All right.
And the options are $12 septillion, $12 octillion.
Here, just give me a moment.
Yes.
And then I'm probably going to want it repeated.
All right.
Okay.
Intense deliberation.
Intense calculation. Okay, so that's 4 pi. And then what's the arc? Let's say 100,000. 140,000. And then that's what squared. Okay. All right. Repeat, please.
The options are 12 septillion dollars, 12 octillion dollars, or 12 nonillion dollars.
Let's see. Yeah, that's what 8. Let's go with. Shoot, wait. Sorry.
It's all good. It's a tough question.
24. Let's go with septillion.
That is correct.
Whew. Wow. Nice.
Very nicely done.
Thank you.
Yeah, very nice. Very nice.
All right.
All right. So.
Your turn.
Wow. We're all the way back to the title slide, folks. I will take technology for 400.
All right, technology for 400. We got. What technology makes SpaceX rockets so cheap?
What technology makes it so cheap? So they're reusable, which that's just overall operations cost makes it cheaper. But if you're talking about the rockets themselves, I'm gonna say it is the materials that go into them. The materials.
You were right about the reusable. It's that's what I said.
So you meant overall, not individual. Yes. So the reusability of rockets.
Yes. And also, I would add this is more of a method, and that's vertical integration. But that also makes it cheaper. Both of those things.
All right. Scoreboard's looking good.
And vertical integration is basically that, because that's a complex sounding. It's basically that they, not only do they like assemble the final pieces of the rocket, but they make the pieces as well. Whereas NASA mostly would, hire, 10 companies to make the pieces, and those 10 companies would hire 10 other companies, and then the price quickly adds up. SpaceX was cutting out the middleman with vertical integration. So yeah. All right. Now it's your turn.
It's your turn. I thought I just answered a question about the SpaceX.
Oh yes, correct. It is my turn. All right, I'll go with physics, true or false.
Yes, physics
or not true or false.
Questions that are in
that is also acceptable.
Way true or false.
All right.
If you want, I can easily make this one true or false.
Nah.
All right. If you want, just say make this a true or false question.
Okay.
If two objects are both moving in a vacuum under all the same conditions, and the second object has twice the mass of the first object and twice the velocity of the first object, what is the ratio of the kinetic energy of the first object to the second object?
So the first object has 1/8 as much as the second object, which is twice as massive and twice as fast.
That is correct. So the ratio would be 1:8.
Yep.
That is correct.
All right. Yes, that has basically just been like my physics class for the last month. Has been doing pretty much just that. So
nice. I'm glad because I didn't go to anything for that. I came up with that. And I haven't taken physics, and I'm going to do that over the summer.
Nice.
So there you go.
Nice. All right.
Everyone at home is screaming for me to pick
a
very certain one, and I will go with
He's not. Oh, he did it. Habitats.
I know. You need to disrupt the medium. You need to
what a legend.
Go against people's expectations.
What a legend. All right. Habitats for 400. How long is the ISS currently funded for by the U.S. government? So periodically, the U.S. government has to have a funding authorization renewal bill.
So and how long? For the year that it needs to be renewed in, or
yeah, pretty much the year that it may be renewed in or may be retired in. Because it might not be renewed.
I'm going to say they probably have to do it. I mean, governments love to make things happen every 20 years. And usually I've found that the range falls anywhere between 20 to 30 years. So I'm going to say that, because I haven't heard, the thing is I haven't heard about anything about that recently, and I don't know if that's just because it hasn't really worked its way into the news, because it's just something that the U.S. government does, like just as a thing, or if it's because it hasn't been done in a while. And if it hasn't been done in a while, that kind of makes me think. So I'm going to kind of split the middle here and say that we last renewed it sometime in the past 10 to 12 years, which would mean that we would need to renew it in, I'm going to say, 2035.
The correct answer is 2030.
2030, all right.
Yeah, even 2030. It might be retired or renewed by then. At that point,
what is the interval?
Yeah. The interval? What do you mean?
That they need to keep renewing it.
Oh, so in 2018, it was only renewed until 2020. Okay, so when 2018 started, it was only renewed until 2024. But when 2018 ended, they had passed a bill to make it 2030. But yeah, so the ISS would be 30 years old at that point, 32 years old.
Wow.
So the question is, should it be retired for a newer one?
Know. Do people retire at 32?
People do not. But how old are the cars in your garage?
Like, disgustingly. I have a Subaru.
Is it 32?
No.
Are you rocking a 1998?
It is definitely not. But you see, you tricked yourself, Max.
Yeah.
I don't keep my cars in the garage.
Wow. Actually, it would be more than 1998 is the ISS in 2030. So you would have to have a 1989 car. Do you have any 1989 cars?
No. My dad used to drive a Saturn, which arguably could have been from 1989, considering how poorly it ran.
All right. But not anymore. Yeah, I think I had a car from a 2003 car that we had for 11 or 12 years or something like that. We don't have it anymore. But we had it for a while. So yeah. I would say the ISS is somewhere between car and person in terms of when it should retire, right?
A strange amalgamation of car and person.
Exactly.
All right.
Actually, I will just add one final point that it would be an interesting argument is that the ISS was built incrementally. So maybe it actually shouldn't ever retire, but pieces should retire and be replaced incrementally by updated versions.
Ship of Theseus.
Ship of Theseus time. International Space Station of Theseus, anyone?
Was that a habitats question?
Yeah.
So I got that one wrong.
Oh shoot, wait. Yeah. You're right. I misplaced. Here, wait. Yeah, that's habitats. All right. I misplaced the red square. Okay. So I will now do astrography.
All right. Astrography.
For
400.
Oh yeah, for 400.
Which planet in our solar system was almost named George?
Oh, Uranus.
That is correct.
Yes. King George.
Yeah. Which King George?
Oh shoot. I don't know, the fourth one?
The third.
The third. There you go. Why are there so many?
Oh, wait until you see how many King Louis there are.
Oh yeah. Yep. And then you also get King Henry.
Oh yeah.
Right? King Henry.
King Charles.
And then the Tsars were all just either Alexander or Nicholas.
Yep.
But yeah. The names are all the same. All right, so what's your first 600?
Let's get it out of the way. Chicago 600.
Yes, Chicago. All right. At one point, Volcanoes were present here. Chicago, Io, both or neither.
Okay. Obviously, there's volcanoes on Io. Were volcanoes present in Chicago? Like, the U.S. isn't. Well, I mean, all of Earth was like volcanic, but I doubt we can. Actually, we might be able to. Is there a volcano? Like, Chicago does not take up that much area. Like, for a city, I don't know the area of Chicago, but I would say that the odds are not in its favor for a volcano to exist on it. So I'm going to say that is just Io.
Correct.
Thank
just
God.
Io.
Oh my God.
Has volcanoes. Yeah. The Chicago volcanoes. Chicago's fun. In history class, it's like the center of like anarchism.
Yeah, honestly,
So,
the Chicago fire, all that stuff.
The Chicago, I think it might have been Chicago, where there was this like huge bombing in like 1906 or something like that. Wait, no, 1906 is the fire, right?
I think.
I don't know. I forget. Chicago be wildin', as the people say in Chicago.
The people.
I don't know. Maybe they do. Maybe. Oh yeah, wait. I gotta add the points here.
Yes.
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 More. All right. Let's go with astrography for 600.
Astrography for 600.
Yep.
How long ago was the Great Red Spot first identified? And I will, you know what? I'll give you a hint here. When I said a certain year sounded familiar, it was in reference to this question.
So it's either, I have two possibilities. It's either the 1830s one or it's 1610, and I would put my money on 1610. Yeah, it's got to be 1610s, somewhere around 1610. There you go. That's my answer.
Unfortunately, that is incorrect. It was the 1830s. I believe it was 190 years ago in 1831, the Great Red Spot was first identified. And it's interesting that it actually wasn't identified in the 1600s, which is what has led people to believe that it simply wasn't there.
Yeah, I would say if it was there, Galileo would have noticed it because he noticed the moons. And the moons, I would say, are probably, the moons are smaller. So you would think, that's basically what my thought process was. You would think that if it was there, if it had been there, that Galileo would have seen it.
Dude, you might get bingo looking at this board.
Bingo. Yes.
We need to make that medal.
Red square bingo.
You get red square bingo.
That's fun.
I probably have gotten that, but not just like a clean line.
True.
But all right.
All right. What's your next?
Let's go with. I'm glad that I redeemed myself in Chicago. So, let's move westward, and let's go to multiple choice for 600.
All right, multiple choice, 600. Okay. How long does it take energy in the center of the sun to reach its surface? 30 days, 1,000 years, 1 million years, or 50 million years?
Say it again.
How long does it take energy in the center of the sun to reach the surface of the sun? 30 days, 1,000 years, 1 million years, or 50 million years?
I'm going to say the third option was 1 million, right?
Correct.
I'm going to say 1 million.
Correct. 1 million years. because it's bouncing
crazy over
bouncing around in there like a what's it called? Pinball. There you go. Pinball machine. That's what's happening.
Very nice. Very nice.
Yeah. All right. I will now choose physics, true or false. And yeah, let's make this a true or false question, if you can.
Yes, I can.
All right.
Archimedes was a Greek mathematician who lived from 287 to 212 BC. That is not part of the question.
Okay.
Which aspect of physics does his principle, dubbed Archimedes' principle, solve for? True or false? This principle, the Archimedes principle, solves for buoyancy.
Buoyancy. It sounds familiar, so I'll say true.
That is correct.
Nice.
That is based on his water displacement thing, which is kind of what he became infamous for getting into a bath that was too full, and he displaced the water, and he said eureka, and he ran up to the king in the full nude. But
Fun.
He would then create his Archimedes principle of buoyancy.
Nice. Here, wait, have I added right? I'm not sure. If we go to the balance slide for both of these.
Let's do a math break.
Yeah, let's do quickly.
You got 800 in the top row. That would be 12.
Yeah.
And then
I'll recount yours, I guess, and you can recount mine. Okay.
We'll store
1,000.
Calculator.
Yeah. 1,000.
You should be at 32. How'd you get 3600?
Huh. You should be at 38.
I'm at 38.
Weird.
And
right. Does that make sense? And then I guess double check yours. Yeah.
You should be at 3200. I don't know if I added wrong.
Okay. Let's see. You're probably right. 1,000 plus.
Oh no! 2, wait, no. There's 6 there, so I think I added it incorrectly.
600. I got 3,600 when I did it again.
Yeah, I did it wrong.
Okay. Okay, so 3,800 and 3,600. Does that make sense?
I believe
so just just recheck yours so that you're happy with it.
1,200, 1,600, and then do those, which is 1,200, 3,800. There we go.
Nice. All right.
Nice. Very nice.
That's where we're at.
Are looking good.
Yeah. Okay.
Right.
Now it's your turn.
I'm going to go for physics. True or false?
All right. Physics, true or false? Okay. 1 joule, the unit of energy, is equivalent to kilograms times meters squared divided by seconds to the power of 3.
Jesus Christ.
So this is another one of those. So this is the unit of energy, kilograms times meters squared divided by seconds to the power of 3. Now try and use my my hint from last time, my sort of advice. Find some equation.
To say that is false.
You are correct. It is false. Nice. Joules are actually kilograms times meters squared divided by seconds squared, not seconds to the 3. And the way I remember that is, of course, the most famous equation of all, E equals mc squared. Because you've got the m, which is kilograms, and you got c, which is a speed, so meters per second, and meters per second squared is meters squared per second squared. So then kilogram meters per second squared.
Very nice.
Yeah. All right. Nice job. 4,400.
Shmoney.
Okay, that's my turn. Shmoney. All right, I'll go with habitats.
Habitats 600.
Yeah.
What are the dimensions of an O'Neill cylinder?
5 miles in diameter,
Mm-hmm.
and 20 miles in length.
Right on the money.
Nice. All right. Yeah, I had a question about them too, so I'm like, okay, I think, like in my research, do I remember? Yes. All right, so now it's your turn.
All right. Oh, I clicked on your actual thing. Oh, what a snipe. How did I hit that X? It was so small. All right. I am going to go for Astrography for 600.
All right. Astrography for 600. How far are we from the center of the galaxy?
Pretty far. From the center, I know
Fair.
we're like on the arms of it, so I'm gonna say we are. God, I don't have like a scale in my head really. Like I know Alpha Centauri is like 4 light years away, and I know some other stuff is like that many. I'm gonna say we are 50, and this is out of nowhere. No, that seems a little extreme. I'm gonna say, you know what? 50 million light years.
We are actually 25,000 light years.
Wow. Okay. Hello.
Yeah. Wouldn't it be nice to have such a large galaxy?
Yeah.
The mega galaxy.
Yeah, that estimate was a tad south or a tad north.
A tad north, yeah. All right. Okay. Now it's my turn. All right. I'll go with technology for 600.
Technology for 600.
Technology.
Which company created the first commercial quantum computer? And
IBM.
That is correct.
Yay. Yes.
The first.
I forget what does IBM stand for. That's like International
Business Machines.
Business. There you go. Yep. I think you're right. Yeah.
Does IBM stand for International Business Machines?
What a fun name.
Yeah.
They were founded in like during World War II, right? For national purposes rather than international. They weren't very international.
It was actually founded in 1911, but I could see.
Oh wow, that's crazy, huh?
Booming during World War II.
Yeah. The point, yeah, they did a lot of contracts with the American government. So, yeah. It would be better NBM, National Business Machines, right? I guess now they're probably international. So yeah.
All right. I'm going to go for habitats for 600.
All right, habitats for 600. Okay. So what is the minimum theoretical radius for a rotating space habitat? And so that is like comfort for a rotating space habitat.
In what unit of measurement?
I said meters, but I can convert if you want.
I'm going to say minimum. It's going to be somewhere near 700. No, that's kind of crazy. Let's go 400 meters.
The answer is actually 20 meters.
What?
And this is at 1/3 of a G.
Oh.
So.
Jeez, don't
4 RPM.
That one. I'll take the next one. Thank you very much. Yeesh.
So this is 20 meters, 4 RPM, and 1/3 of a G, which is like interesting.
Yeah, I was thinking big scale, but yeah.
Yeah, I'm trying to think because a big thing in that, I'm gonna pull up a calc tool for a second. A big thing about that is the body gradient. So it's like your feet, how much gravity they experience compared to your head, right? Mm-hmm. And so if we do 20 meters and 4 RPM, right? Then we get, for your feet, you get 0.357838. And then for your head, let's say that you are 1.5 meters tall. It's 18.5. Or let's just round it off to 2. Say you're 2 meters tall. Then the answer is 0.322054. And so the gradient there is 0.035. So for the average person, maybe 0.03. So your feet are being pulled on by 0.03 G more than your head. So I guess that's tolerable, right? Yeah. I looked at a study. I was surprised too. I thought it was higher, but anyway. So yeah. Let's see. That was I'm tired, man. Okay. There we go. Maybe I need to turn down my screen brightness. That might be a good idea. Okay. Now it's my turn. I'll go with Alpha Centauri for 600.
And he's stepping right back into real estate. How are you doing,
my friend? I'm doing well, my friend.
Age is a very important factor when looking at a property. Our analysts have found that the price of a property drops by 0.01% every year. Based on this, and given that the price of Alpha Centauri would usually be listed at around $12 septillion, if you take age into account, how much would it cost today?
Oh my gosh. Okay. So
its initial amount is the $12 septillion.
Can I do the calculator?
You can. Calculator is permitted on this section of the test.
Okay, of the test, yeah. I'm going to guess that the system is 7 billion years old. So let's put that in. Let's just do that as the thing. So 0.01, or well, actually, this is 0.01% decrease. So that really means 0.9999, I believe, right? 4 nines, because, yeah. Okay, so then that to the power of 7, 1, 2, 3, 1, 2, 3, 1, 2, 3, gives you 0. Thank you, calculator. It gave me 0. Okay, let's try that again. Okay. The power of 7. Well, let's see. 7, 1, 2, 3, 1, 2, 3, 1, 2. The power of 0.5. 0.9999. Power of 83666. Okay, great. So then I can square that. And now that times 12 septillion. And 12 septillion is 12 times 10 to the power of 24. So that gives me an estimate. Let me convert that to human words instead of scientific notation. So 10 to the 15 is it's quadrillion, yeah. So that is $648 quadrillion. That is my final answer.
Actually, your first answer was correct. it really would be 0. It would be free.
It would be free
by that point.
No way.
Yeah, because it's a percentage.
Oh, you mean like?
No, you're doing it right with the 9999.
Yeah.
It's just because that catches up because so Alpha Centauri is 5.3 billion years old. So 5.3 billion, and again, you just use the exponential decay thing. It's obviously not actually 0, but it's a negligible amount of number.
Are you sure about that?
I think I'm pretty certain. We could reverse.
What calculator did you use?
My TI-84 Plus CE Gold Edition.
So I also did that, right?
Yes.
And when I first put in 7 billion, it gave me 0.
It did.
But then you see what I did.
What'd you do?
Actually, you're right. Never mind. I think. Wait.
Do you want to reverse log it?
Here, wait. I'm just trying to think. If you were to put in...
Because what I actually did an extra thing, and I found what it... I used... This was before I was actually using an estimate of $9 septillion for the cost estimate, so 9 to the power of 10 to the 21st. And I found that
okay, you're right.
It
you're right.
$1 after 500,000 years. So,
yeah, you're right. You are correct.
All right.
I miscalculated. Yeah.
It took me a while to get to that because I had to keep checking my numbers.
Yep. I did not do my exponent rules correctly. That's the problem.
It was a tough question.
That was a tough question.
These Alpha Centauri questions are actually probably the harder ones on here.
They are pretty difficult. Yeah. All right. Now it's your turn.
I'm going to go with... There's a very obvious choice. And you know what you got to do? You got to please the people. So I'm going to go with multiple choice for $800.
Oh, that's like in Tetris. You're like... It's like right there, but then it lands right next to it.
Yep.
All right. Multiple choice. For 800. Which is the tallest mountain from base to peak in the solar system?
No, you're lying. Oh my god, I have a question very, very similar to that.
All right, so the answers are Busale Montes on Io, Iapetus Equatorial Ridge on Iapetus, obviously, Olympus Mons on Mars, or Rhea Silvia Peak on Vesta.
I am gonna say, because I was just looking at it, I'm gonna say it has to be Olympus Mons just because of how tall it is. Its base to height is like, its base to peak is like 20 kilometers, which is insane. I'm gonna say it's Olympus Mons.
It is actually Rhea Silvia on Vesta.
How tall is that?
It is, so Olympus Mons is 21.9 kilometers, and Rhea Silvia is a full 22 kilometers.
Dang.
I didn't know that either, actually, when I looked it up.
Scary.
I was going to put that as like the 400 question because I thought it was Olympus Mons too, but then they're like, no, it is actually Rhea Silvia. And I'm like, oh, shoot.
I should have known it was a trap.
Rhea frickin' Silvia.
There's no way I could have gotten that.
Yeah, that was a hard one.
That's a tough one.
So I guess the distinction is whenever people say Olympus Mons is the tallest, blah, 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 they actually mean it's the tallest on a planet because Vesta's an asteroid. So I never knew that hidden asterisk was there, you know?
Yeah.
Anyway, I shall now pick multiple choice for 600 as well.
All right. So, we can call the stars in the Alpha Centauri system Alpha Centauri A, Alpha Centauri B, Alpha Centauri C, if it so pleases you, but they all actually have official names. So, which of the following names are not official names of stars in the Alpha Centauri system? And again, I apologize for messed up pronunciations, but I can spell them if need be. So which of the following are not official names of stars in the Alpha Centauri system? Ptolemy, Rigil Kentaurus, Proxima Centauri, or Phaera Kentaurus?
What was the first one?
The first one was Ptolemy, or Ptoleman. It's spelled Toliman.
And then what was the second one?
Rigil Kentaurus, spelled Rigil space Kentaurus.
All right, and then what was the last one?
The last one was Phaera Kentaurus. Kentaurus is spelled the same way, and Phaera is spelled Farra.
Oh no, these are all very convincing. So nice job.
Thank you.
So they all sound vaguely like Sumerian or something, right? And so I'm like, which one of these sounds out of place? That's
actually how I got the idea for which one the fake one is. So I will give you that hint because I stumbled on that.
All right. Let's go with Coolaman or whatever, the first one.
That is actually an official name of Alpha Centauri B.
All right.
And used to be the official name of Alpha Centauri A back when they thought they were just the same star. Rigil Kentaurus is now the official name for Alpha Centauri A. Proxima Centauri is Alpha Centauri C. But Phaera Kentaurus is not an official name of any star in the Alpha Centauri system. And yeah, you completely nailed how I came up with the name for it, because I went to Arabic and I got I just put in different variations of horse. So I think I landed on steed, and steed landed on Ferris, and I was like, all right, so Phaera Kentaurus. Rigil Kentaurus is the wriggle part is in relation to something relating to a horse, I believe.
Interesting.
Yeah,
that's very fascinating.
That was a tough one.
Yeah. All right. Now it's your turn.
Oh, man. Let's go technology for 600 before I go further into the deep end of the pool.
All right. Technology. When was the first man-made object launched into space?
All right. That was Sputnik.
Yeah.
Sputnik was the first man-made object. Oh my god.
Yeah, I'll give you plus or minus 2 years.
Plus or minus 2 years. All right, so it must have been at the start. Oh, wait. I just watched The Iron Giant, and they have it in the first scene.
Yes.
Yeah, it was, yeah, I know it was like
great.
Late 50s, early 60s. I'm going to say, because of the plus or minus, I'm going to say 1960.
It is actually 1957.
Oh my god! Come on!
Yeah.
Boo!
Boo!
Boo! You stupid Soviets! Why couldn't you take it a year longer, you ass? Oh my god.
Yes. I think it's October 4th, 1957.
Yep.
I think that should be a national holiday.
Yeah, no, I should know that. That's ridiculous that I don't know that.
Yeah.
Oh, I've let everyone down.
It is all right. Well, because the question is, should it be a national holiday? Because, it's the Soviets, so, why should we celebrate that?
It's true.
That's the most, I guess, predictable argument, I would say. But I would argue it should be an international holiday. There you go. International Sputnik Day, October 4th. There's an International Everything Day, right? Like donuts and stuff.
We celebrate it by launching a child into space.
Uh-oh.
I know that I'm the same weight as Sputnik. Sputnik weighed about 145 pounds. So,
wow.
if you want to launch me into space to commemorate it, go ahead.
Sort of like the Elon Musk Tesla.
Yes.
Like they just needed something that weighed that much for the test. All right. So next I shall go with physics, true or false, for 800.
And I will make this a true or false question because we are dealing with big bucks.
All right.
What is the range? Okay, so I'm going to give you a range of this, and you're going to say, all right, no, that is not the final point, or you're going to say, yes, that is the final point. So I guess, is the range of Earth's gravity, so the point where there is absolute 0 degree of Earth's gravity affecting an object, 150,000 kilometers above the surface of Earth?
False, because the moon is farther.
I'm pretty sure. That is correct. And technically, there really is none because gravity does have infinite range.
Yeah. I thought you meant like hill sphere. That's what I was thinking. But
there you go.
Yeah. So gravity does have infinite range. Yeah. All right. Yeah, if it was something that I couldn't immediately rule out, I would have asked, do you mean hill sphere or not? But and the hill sphere, for anyone at home, that would be basically the point at which the sun's gravity is stronger than Earth's gravity. So Earth still has gravity. It has gravity out to an infinite distance. But the sun is overpowering it, and then eventually all of space overpowers it. So it just becomes background noise. But yeah. All right. Now it's your turn.
All right. And have the balances been updated?
I believe so, yeah.
All right. We will do another math check a little while into the future.
We'll do it before we get to the thousands.
All right.
We'll do all the 800s.
And when we get to the thousands, we will be making use of the game element. I don't know if we fully explained it at the beginning because of me doing on-stream editing. So really quick, what it is on my board, I have the power of Gravity Min, the dark version of Gravity Max, and Max has 49 seconds, the dark version of 128 seconds, and basically the game element is we call on each other's evil arch nemesis, and basically we do that on our turn, and that means that on our opponent's next turn, they can lose money for answering the question wrong. Currently, we don't lose any money, we just don't gain money. If they answer it wrong, they lose money.
Yep. Here's a question. When are you allowed to apply it? Is it before or after they pick which topic?
It is. You have to do it on your turn before the other before it even is the other person's turn, and you only get one. You only get one.
All right.
And it's pretty powerful because you can deprive someone of $2,000 potential dollars.
Yeah. Pretty much. Right. Net. You mean, right? Yes. You can't actually lose 2,000, but yeah. Yes. All right.
All right. Is it me?
Yes.
All right. My oldest enemy. Chicago.
All right. So. Okay. So, is this thing the third largest city in the country or the third largest moon of Jupiter, right? Are they the third largest of their kind? Is that Chicago, Io, both, or neither?
Okay. I know Chicago is part of the big three, meaning New York, LA, and Chicago. Although, we Americans are sometimes bad at naming things. But I'm going to give Americans the benefit of the doubt and say, yes, Chicago is this nation's third largest city. Do you mean in terms of, like, population?
Yeah. So for cities, it would be population. For moons, it would be mass.
Yes. Okay. So I'm going to say, yes, Chicago is the third. And, okay. I know Ganymede is the largest. I think Europa is next, and then it's Io, and then it's Callisto, so that would also make Io 3, so I'm going to say that's both.
Correct, it is
Woo!
both.
That
Although
knowledge.
the order is incorrect. It's actually Ganymede, Callisto, Io, then Europa, but those are the two that don't matter at all, so nice job.
There you go.
They don't matter for the sake of that question, so you got it right. All right. Nice. Okay, now it's my turn.
Proud of that one.
Yeah, nice job.
Thank you.
I will go with habitats for 800.
Habitats for 800. Contrary to NASA's proposals in the 1970s, Forrest Bishop foresaw his bishop rings existing at the Lagrangian points between which two heavenly bodies? So NASA in the 1970s suggested placing it at Lagrangian points between a different pairing of heavenly bodies. And Forrest Bishop had a different idea. What was his idea?
Moon and Earth.
That is incorrect. That was NASA's proposal.
Forrest Bishop and his was Earth and Sun.
Earth and the Sun.
Yeah. I was just 50-50 there. It was really either of those two. All right. I'm gonna get bingo.
Dude, you might! Oh my god, this is insane.
Oh, it's so funny.
This is crazy. You just... Oh my god.
This is not intentional. Oh boy.
That's... I don't even know. I don't even know what the word for that is.
All right.
Here, let's see how hard it is. Okay, yeah, you might get the final physics one right. Although it is the true or false. So. All right. Physics true or false 800.
All righty. Okay. Mercury's orbit was key to proving Newton's theory of gravity. True or false?
I know Mercury was used in very specific calculations that did help to prove a law. I don't know if it was Newton, which is the thing, because I think, this is my hypothesis, I think that might have been Kepler that used Mercury, because that's ringing a couple of bells. Is that Kepler, because Kepler's first law is that things move in an elliptical orbit. And Newton couldn't really... Or did Kepler come before Newton? God damn it, I'm forgetting our own history. Because it was Tycho Brahe. And Tycho Brahe taught Kepler. So Kepler had to have come before Newton. So I'm going to say that it was not Newton, it was Kepler. So I'm going to say that is false.
Correct.
Oh, am I right on the Kepler?
It's actually Einstein.
It's Einstein.
I thought.
Okay.
Basically, Newton's theories led to inconsistencies with Mercury's orbit.
Right. Yeah, that's it.
And then relativity sort of smoothed those over, by suggesting that gravity moves at the speed of light. Because since Mercury is so close and it moves so fast around, relativistic effects, like slight relativistic effects, very slight, actually came into play noticeably. So yeah, correct. The Mercury's orbit was key to disproving Newton's theory, really, if you think about it, right? So yeah. All right.
If I get that last physics, I will get the physics medal, and I will be set for my summer class.
Nice. All right. So I will go with technology for 800.
Beep, boop. Which of the following animals have never... I mean, like I say which, but that means there's only one correct answer.
Okay.
Which of the following animals have never had their genes cloned by humans? Horses, frogs, snakes, wolves.
Horses, frogs, snakes, or wolves?
And it doesn't have to be a full cloning, it's just their genes were cloned.
So horses makes me think of like sheep that we did it. So I would imagine yes there. Frogs, it makes me think of like Jurassic Park. So I'm like, yeah. Right. Because I imagine that was like the inspiration. And then snakes, I would just go with yes as well because of reptilian. I guess if you think of all those animals, wolves are the only ones that like are not domesticated at all, right? Like sure there are wild snakes, but there are also domesticated snakes. So I would imagine wolves would be the hardest to handle. So wolves, that would be my guess.
The correct answer is snakes, unfortunately.
Really? Wow.
It was not American scientists that did wolves, I believe.
Okay.
So maybe they knew how to tame them better. It was South Korean researchers cloned the endangered gray wolf. This was in 2005. Horses were in 2003 in Italy.
Honestly, good with the snakes though, because like when you clone a gene, right? It's the purpose is to insert that gene into another organism. So I'm glad that we're not making things more snake-like.
100%. You completely nailed the frogs thing. Because that happened in the early 70s, and they were not able to make a full clone of a frog like they were the horse or the wolf, but they were able to clone its genes. But this has never been done with snakes.
Interesting. So I guess we just have more knowledge about the mammals.
Yeah.
So.
Yeah, definitely more mammals than anything else, because I was looking at a list. There were mice, rabbits, goats, sheep, obviously, all that stuff.
Oh yeah, big on the mice one. A lot of lab mice now are cloned not for the purpose of like experimenting on clones, but just as like part of it's for standardization if you think about it. That's the reason. It's like you want, if you're going to use a kilogram, it has to actually be a kilogram, right? You know, like if you have a substance, say, if you're going to use in an experiment like gold, it matters that it's like some purity of gold, right?
Yeah.
Same thing with the lab mice. Because of like genetic differences, it can cause differences in the experiment. So now they're moving toward like cloning mice and having it so that it's like the exact same DNA being experimented on. And that has both benefits and drawbacks, I would say. Because like one disease and like, oh, all the mice are dead.
Yep.
But also it's like, it does make the experiments more reliable. But then I guess you could also say that it makes the experiments sort of like less reliable in a way. Like it's more reliable in that it's more reproducible, which is a big thing in science, is that you want an experiment to be able to be copied by another person.
Yep.
But if, like, the experiment, first off, when we experiment on mice, it only tells us that this is true for mice, and we just generally correlate, like, sometimes that is related to how this, like, drug might affect humans, right? But if you're experimenting on just one specific mouse, right? Because if they all have the same genes, they're essentially the same mouse. Then doing that experiment is just telling us about that one specific mouse, not even the whole mice population or even the whole human population. So it's an interesting conundrum, I would say. I would guess it would have to be an experiment by experiment basis on which it might be useful and it might be detrimental. But yeah, there's my analysis.
Very nice.
So yeah, now it's your turn.
All right, I am gonna go for. All right, physics is the only pure category left, but I will stay in the 800s for now. Let's go technology 800.
All right, techno 800. All right, so technology. Okay. What is the closest object to the sun? And I will add, it is a man-made object.
Oh no. It was a probe that was sent to Mercury. There were two. It was, the two that were sent were Messenger, which I think is going to be my answer, but I'm not answering yet. It was Messenger, and then it was, I forget the name of the other one, but I covered this in my Mercury video. I'm gonna say it's Messenger.
It is actually the Parker Solar Probe.
Oh, god damn it. Okay, fucking Parker. Oh,
we sent it.
F-bomb.
We sent it to the sun, unironically. Unironically, we sent it to the sun. It got really close to the sun, and in a few years, it's going to get even closer. Like, it's doing like an elliptical passing thing, mm-hmm. And it'll get as close as 0.046 astronomical units from the sun. It's already within the orbit of Mercury, but it will get that is 4.3 million miles. It is like skimming the surface of the sun. So yeah, very, very cool. Yeah, all right. So now it's my turn. Let's just do like multiple choice for 800.
All right, I'm going to give you 3 options for this.
All right.
What is the ratio of Pluto's mass to Sedna's estimated mass? Is this ratio for Pluto to Sedna, in terms of mass, 10 to 3, 5 to 3, or 8 to 5?
Those are the 10 to 3, 8 to 3.
10 to 3, 5 to 3, 8 to 5.
5 to 3.
It is a 10 to 3 ratio.
Unfortunate. All right. Sedna is a small boy. That is the conclusion here.
Its estimated mass is anywhere from, I believe, 1.6 to 6.2 times 10 to the 21 kilograms. And Pluto's mass is, it's in the 10 to the 22 area. I think it's 3 times 10 to the 3.2 times 10 to the 22, which gives you if you just take the average of that estimation for Sedna, that gives you a 10 to 3 ratio.
Nice. All right. Now it's your turn.
It's getting hard. It is getting hard. I almost have like a reverse bingo going on.
Yeah.
Let's go Habitats 800.
All right. Habitats 800. All right. At the population density of your town, right? Our town, hometown. So around there, right?
Yeah.
How many people can fit in an O'Neill cylinder?
All right.
And this is the same dimensions that we discussed before.
So, yes, the dimensions were 20 by 5 miles.
Yep. Yeah. So with Westport, I mean,
they know.
They know. With the Westport population.
Don't worry, I'm moving soon.
He's moving.
Just for college.
Right, yeah.
Okay. What the fuck is the population density? Oh, there's a second of Westport.
Uh-oh, now we are R-rated.
This is an R-rated stream.
What have we become?
I don't know.
Yeah.
I'm just estimating, like, what is the square? How many square miles? Like, I'm gonna. What the hell is the population density? Saying we probably have an area of. What the hell is a square mile? I'm using my calculator. It's probably more than that. All right. How many people could fit? So. At this. Okay. So off the top of my head, I don't know the equation for area or surface area of a cylinder. Do I need that for this question?
I mean, it would be helpful because that's the surface area. Well, I mean, I'm just going to tell it to you just because it's very simple. It's just the circumference of the cylinder times the length of the cylinder.
Mm-hmm.
And the circumference is just diameter times 2 pi.
Right.
Or not 2 pi, 1 pi. But
diameter times pi. So, yeah. So you said it was just diameter times or circumference times the length?
Yep. Because imagine unwrapping it.
Right. Oh, right, yeah, you're right. So that'd be that. So then you get that. So that's like that. The population density of... I'm gonna assume that. So that's in square miles. So I'm gonna say it could harbor, and I'm rounding here, 250,000 people.
I'll give you that.
Ooh.
I have like 800,000, but I'm thinking like.
What was your population density?
Let's see. I'll pull it up. Well, so it depends because yours could be factoring in the mirrors, right? If you factor in the mirrors, then it's only 400,000. So I didn't factor in the mirrors. But yeah. So the glass layout. Okay. Yeah.
Ooh.
Population density.
Yeah, it's saying 1,300.
Yeah.
Square.
13,222.
I was using an estimate of 800 per square mile.
Ah, yeah. It's a bit denser than you thought, huh?
Yeah.
Actually, I may have made an error in my code. So let me recalculate. I'm pretty sure that you're like even more correct. Okay, yeah, I made an error. The error was I treated the 5 miles as a radius instead of a diameter. So the answer is actually, excluding the glass lands, it's 400,000. So you're like spot on. If you include the glass lands for aesthetic purposes, then it's 200. So you're right there in the range between the two possibilities. So there you go. The glass lands. To include or not to include the glass land. The eternal dilemma of the next generation. All right, let's go with astrography for 800.
Excluding Earth, on which planet could you find Rembrandt and Beethoven?
Ah, that would be Mercury, my good sir.
That is correct.
Yeah, because the craters are named after artists.
Yes. I had to throw in the excluding Earth.
Yep. Yeah. That's an important one. Nice. All right. So, yeah. Now, let's see. Now it's your turn.
All right, let's finish off the 800s. Astrography 800.
All right. Astrography. Okay, astrography. How long does it take to communicate one way with Neptune? So, how long does it take light to get from Earth to Neptune on average?
Okay, so it takes light 8 minutes to get here. That's 1 AU. So light can do 1 AU in 8 minutes. I'm gonna say Neptune is ridiculously far away. I believe it is somewhere like, how far is Neptune from the sun? I'm just gonna use a calculator here. If we have, I'm gonna say it's 120 AU maybe. That's 60 minutes divided by 60. So just one way.
Yeah.
That seems light. Hold on. Let's see. I'm gonna say it takes. Again, that still seems light. I'm gonna say it takes 30 hours one way.
Actually, just takes 4 hours.
Wow.
Yeah.
So it's only. That would mean it's. How far away is it? How many AU is that?
It's about 40.
Yeah. Okay. My initial thing, I was gonna say it was 60 AU away, and then I was like, "There's no way." But 40. Okay. All right, I could rock with 40.
Yeah. Here, wait, let me check. Oh, it's actually here. Wait. Oh my god. I'm sorry. This is so fucking Number 3. Okay. So first, I look up Neptune distance from the sun, and it gives it to me in miles. All right, understandable. Wow. I didn't specify. But then when I say Neptune distance from the sun, AU, it gives me light years, as if to say, screw you. Why do you want to know? Okay, so let's see. Here it says 30 astronomical units. So that's even less. So that's like 3 hours maybe.
Yeah.
So yeah. All right.
I was thinking of its orbital period. That's where I got the number like 120, 160 stuck in my head. All right. Let's do a math check. Let's make sure that our scores.
Yes. Here, wait. I have one more thing here, and then we'll do the math check.
Oh, sorry about that.
Yeah. No problem. All right. Alpha Centauri for 800.
Alpha Centauri for 800. When you're in the business of real estate, everyone needs a good agent.
All right.
Who was the, air quotes, agent who first scouted out Alpha Centauri A and B, which he actually believed to be the same star?
Oh man.
I'll give you a time frame of when he lived, and it was a he.
Okay.
He lived from give or take 100 to 170 AD.
Oh man, this is
around the Roman Empire.
The Roman Empire. Oh jeez, I'm not gonna.
I would bet you know his name.
Oh. Okay. See, I feel like all the people I know are Greek. Okay, let's go with Pythagoras. Is it Pythagoras?
It is not Pythagoras. I feel like this guy might be Greek. He just operated around the Roman Empire. But it is Ptolemy, actually.
Oh, okay. All right. I'll take the L there. I would not have I did know of there are a lot of Ptolemies though.
Claudius Ptolemy.
Yeah. My second guess was going to be like Aristotle, so I was not close. Yeah, no, Ptolemy was a big astronomer actually. Egyptian. Well, he was Greek, but he ruled Egypt. That was actually, I think we actually had that a few game shows ago.
Yeah, how Cleopatra was actually
not
Egyptian.
Cleopatra.
That messes me up on a daily basis.
Cleopatra was Greek because she's part of the Ptolemy line.
Yeah.
So yeah.
All right, math check.
All right, yeah, I'll math check.
I'll look at your
All right.
score.
Yeah, I'll do both. So I'll start with yours. So Sebastian. All right. Okay, you should actually have 6,800 according to my recalculation, and then for myself.
You should have 6,400. I will cycle back to me.
All right. 5 times 200.
Or, yeah, in 1, 6, 18.
Yep. Okay. I got 6,400 for myself. So yeah, just make sure for you, the thing said 6,600, but I recalculated 6,800. So you'll be the tie-breaking here. What's the correct answer?
5 200s. I got 4 400s. I got 3 600s. I got 3 800s. So that is U plus U plus U plus U. 6,800.
All right. There we go.
All right. The competition is close. It is anyone's game. This is the state of the game currently.
Yes.
And now the game element will come into play.
Now it is your turn.
Let's put the Windy City to rest. Chicago. It's time.
Yes, Chicago. Okay. All right. Your final Chicago question is, okay, which place can reach a partial pressure of sulfur dioxide of 100 nanobars? Chicago, Io, both, or neither?
Sulfur dioxide. Okay. Io has a lot of volcanoes. Volcanoes kick up carbon dioxide. But Io just seems like a relatively terrible place, much like Chicago. So I would estimate that there probably is a strong amount of sulfur there. And Chicago is just nasty as hell. Like, but again, the primary thing coming off of it is carbon dioxide. It's either both or not. Oh, you know what? Just to stay, I don't know. Does Io have sulfur? Just Chicago.
Yes.
Yeah.
So it's a really funny. This is actually a really funny one. So Io's atmosphere is 100%, or well, 90% sulfur dioxide. Nice. Yet it's just thinner. At most, it reaches 40 nanobars. So Chicago has more sulfur dioxide, which is this toxic pollutant, on bad days. It can depend, but it can actually reach 100 nanobars, which is worse than literal volcanic hell IO.
I'm so sorry for everyone at home. I must have blown out your ears.
I just find this one so funny. Not to rag on Chicago. Well, whatever.
F Chicago, man.
Oh, Chicago. Poor Chicago. Anyway, all right. So, now it's my turn. I'll pick multiple choice for 1,000.
Multiple choice. Which of these following STS ships did not experience a catastrophic failure? STS-51-L, STS-34, STS-107.
Okay, which didn't experience?
Did not. 2 out of these
catastrophic
3 experienced a catastrophic failure.
Okay. 34, 51, and 107 are the
STS-51-L, STS-34, STS-107.
No failure on the 34.
That is correct.
Nice.
STS-51-L is the Challenger.
Yep.
STS-107 is the Columbia.
I was thinking the L must have stood for something peculiar about it. And I'm like, what's the peculiar thing? That's the only time that they really ever had a, just member of the public, not part of the astronaut program. As part of the thing. So I'm like, okay. And then I'm like, if that's Challenger, then Columbia has to be afterwards. So, yeah.
Very nice.
Very interesting. Unfortunate.
Nice. Yeah. So not very nice, but
not very nice. Yeah. Anyway. All right. Yeah, I hate when there's a trivia, like, it feels really good when you get a trivia, especially like a hard trivia question right, but then when it's about like a serious subject, you kind of feel bad.
Yeah.
Oh, I shouldn't feel good about getting this. But
yeah.
But yeah. Anyway, now it is your turn.
All right, I really want to ace physics. I really do. Physics, true or false?
All righty. Physics, true or false? Okay. Okay, so the cosmic microwave background is now at a temperature of 3 Kelvin, but it started out at a temperature of 3,000 Kelvin when it first formed. True or false? So I will say the first part is definitely true. What is in question was it at 3,000 Kelvin when it first formed?
3,000 Kelvin. Like when the universe formed?
So it's an event called last scattering, which occurred 380,000 years after the Big Bang. And this is the moment where, before this, the universe was opaque. So it was so dense that light bounced around like it was in a pinball machine. Just like basically the entire universe was the center of a star, right? But then after, the universe became transparent, and so light was able to travel freely. And that event, that last scattering event, created the microwave background. And as the universe expanded, the temperature of the microwave background decreased, so that today it is at 3 Kelvin. So the true or false question is, when the last scattering occurred, essentially what was the temperature of the universe? And by proxy, the microwave background.
I'm going to say false.
It's actually true.
No, I can't believe it. I messed up physics. I was going to get that medal. I was gonna get that medal. Oh my god.
That is unfortunate.
Pain. All right.
Pain.
And for that, I would like to enact.
Oh no.
I am unleashing Gravity Min.
Oh no. So
you will now lose $1,000.
If I get this wrong. So my gut instinct, right, is to say, okay, which category have I gotten 100% correct so far? However, if you look at the bingo, then it suggests a worrying trend.
You've done well in habitats and astrography.
So the question is, do I go with superstition? Why not? Let's go with superstition. Astrography.
Astrography? 1,000.
Yeah.
This is very similar to a question you asked me, although it takes it a step farther.
All right.
Rank these mountains. I'm going to give you 5 mountains. Rank these 5 mountains from tallest to shortest based on base to peak height. These 5 mountains are Caloris Montes, Scotty Mons, Mauna Kea, Olympus Mons, and Mount Everest. I can say.
Okay, Olympus Mons at the top.
You can like write it down too.
Yeah, I should do that actually. All right, let me get less scrap paper. There we go. Physics test. All right. Okay, so we've got, what were the mountains again?
Caloris Montes, Scotty Mons, which is spelled Skadi.
Wait. SK. Oh my god. That literally every letter after S was incorrect. I spelled it like beam me up, Scotty.
That one you might also know by a different name, so I will give you that name after this.
Okay.
Mauna Kea, Olympus Mons, Mount Everest. And the name you might know... I gotta bring it back up. Please hold. Scotty Mons, you might also know as Maxwell Montes.
Ah, yes, Maxwell Montes. Venus. All right. Okay. I am well acquainted with Maxwell Montes because it's in my book, in the 3rd book. All right, so, okay. So Olympus Mons has to be 1. Mount Everest has to be greater than Mauna Kea. I'm going to say Maxwell is above Everest. Then what about Caloris? Now I'm going to guess Caloris is on the moon. It's either on the moon or Mercury. I'd say Mercury, actually. Mercury.
Remember what the scale is here. That it is based on base to peak height.
All right. Oh, so then it's not going to be... Okay, it's not Everest then, yeah. Okay, Mauna Kea is actually taller than Everest. Okay, let's just go with that. Okay, here we go. We got number 1, Olympus Mons. Number 2, Scotty Mons. Number 3, Mauna Kea. Number 4, Caloris Mons. Number 5, Mount Everest.
I'm sorry, that is not correct.
Oh.
The correct order is first, Olympus Mons. Second, Mauna Kea. Third, Scotty Mons, aka Maxwell Montes.
All right.
Fourth, Mount Everest. Fifth, Calorus Montes.
Okay. Interessant.
And Calorus Montes is on Mercury.
Okay. Cool.
That one was a very tough one. And unfortunately, the Wrath.
Yes. The Wrath.
The Wrath.
Oh, no. Okay. It gets to be barbecue sauce colored. There you go.
Right. And now his power has been used. So Gravity Men.
And I will now use
Fade away.
the 49 seconds on you.
Oh, the Wrath of 49.
The Wrath of 49. So
yeah, we can take Gravity Men away. They've both been used.
Yep. Right. Now it's your turn.
So now there's a lot on the line here. A lot on the line. Going by history, I've done the best with multiple choice. Let's say Lady Luck is on my side.
Oh, yeah. All right. Okay. The Hertzsprung-Russell diagram directly compares which two stellar properties? I guess you could write this down, but I could just repeat it. So which two stellar properties? Shape and temperature, temperature and luminosity, color and mass, or radius and luminosity?
It's definitely either the second or the third. It is definitely either temperature and luminosity or color and... Well, it was color and what?
Mass.
Color and mass. That's ringing a bell. That is ringing a bell. It's either the second or the third. I'm saying it's third. Color and mass.
It is the second. Temperature and luminosity.
Damn.
Yeah.
Damn.
Yep.
Oh no, the barbecue sauce.
The barbecue sauce. Yum. There you go. All right.
That's $1,000 I've lost.
Yeah. All right. Let's go to Alpha Centauri.
He's going to close out his real estate deal.
Yeah. The real estate.
The final thing that needs to be taken into account when you're looking at the real estate value of a house is the competition of the market. What are the only two stars in the sky that are brighter than Alpha Centauri A?
Sirius, obviously. But then what's the other one? Got a few contenders.
Let's hear
There's Vega. There's Betelgeuse. Rigel. Let's see. Sirius. Let's go with Vega.
The correct answer is Sirius and Canopus.
Oh, I forgot about that one. Yeah.
So
forgot about Canopus.
I want to see where you said Vega. I want to see where that's ranked. Brightest stars. Oh wait, no, that's because of it in the sky. Vega is like right below it.
Number 4 then?
Yeah.
Oof.
I'm actually seeing that there might be, although that's comparing it with absolute magnitude. Right, stars. All right, if this also says that there's actually another one above Alpha Centauri A, I will allow you to try and guess what that one is.
All right.
But no, it is not saying that. This
okay.
next list is not. The one that I saw that might have been above it was Arcturus. So Arcturus would be 4th, Vega is 5th.
Okay. Yeah, Arcturus. Oh, yes. Arcturus makes an appearance in the movie Passengers. You know, that one with the...
Yeah.
The one that should actually be, you know, Tarantino'd or whatever.
It should be, yeah.
It should be. It should be Tarantino. All right. So now it's your turn.
We are on pretty equal footing.
Yeah.
Anyone's game.
This is a close match. All right.
Go technology for 1,000.
All right. Technology for 1K. All right. How far away is Voyager 1?
So it just crossed outside of the bounds of the solar system. Right? I think. Yes. Wait. Maybe. Yes. So that, and we just learned that Neptune is 30 astronomical units away. So I'm going to say that the edge of the universe has to be somewhere around, or not the edge of the universe, the edge of the solar system has to be somewhere around that bounds. I'm going to say it is 30. I'm giving you this in astronomical units. Say it is 33 astronomical units away.
It's actually 152 astronomical units away.
What?
Yes.
That's insane. Okay.
Yeah, it's pretty far. How many years? It launched in 1977, right?
That is true.
So I'm just superfluous calculating here. I just don't feel like it right now to do the math in my head. Okay, that's 44 years, so it's pulling, you know, 3.4 AUs per year.
God damn, that thing moving.
It do be. It is moving.
Right.
Vibing. Just playing Johnny Be Good. Yes. All right. Physics, true or false? Let's do it.
Oh, you can also get the physics medal unless you get bingo.
Yeah.
Either way it goes, you are getting a medal, sir.
Okay.
All right. And I will make this a true or false question.
All right.
Give me 1 minute, just so I can say this without any lag in my speech. So you do not know if it is true, do not know if it is false. Due to time dilation, time actually moves slower on the ISS. That is not the true or false part. This is the true or false part. True or false? Every year, every Earth year, the ISS lags 0.01 seconds behind Earth. True or false?
False. It's more.
That is true.
Or well, wait. Am I correct, or is the answer true?
The answer is true.
Oh, okay. All right.
I will double check that.
Okay.
Time lagging approximately 0.01 seconds for every 12 Earth months passed.
All right. Yeah. Yeah, you're right. I always thought it was more. Huh? Okay, bingo.
Bingo.
No.
We got bingo. We were both snubbed the physics medal.
Stupid. Yeah. All right. Wow. Now it's your turn.
Wow. All right.
Wow.
Let's go habitats. $1,000.
All right, habitats. habitats. How much more surface area does Larry Niven's ring world have than Earth? So what factor? How much larger is ring world than Earth in terms of surface area?
It's an increase, right?
Oh, yeah.
I'm gonna say ring world has How big did Larry Niven go? How big did this mad lad go? Let's think, gentlemen. 6 times. Is it 10 times?
That is
10 times was also flying around my head. What is it?
3 million.
Okay. All right.
Okay.
3 million?
Yes. 3 million. So here's the here. Let me pull up the Ring World wiki. Okay.
What do you think?
Ring
with that much space?
Okay. So the ring world, right, has a radius of 9.5 times 10 to the 7 miles, or about 1 astronomical unit, right? And so it has a circumference of 6 times 10 to the 8 miles. And then it has a width of about 1 million miles. So that's like the thickness of the ring. So now if you think about that, right, 6 times 10 to the 8 miles is the circumference. 10 to the power of 8. And the Earth has a surface area of 196, say 200 million miles square. So 200, or square miles, sorry. 200, 1, 2, 3, 1, 2, 3. And then divided by whatever, 6 times 10 to the 8. So for the ring world to have the same surface area as the Earth, it would have to be only 1/3 of a mile thick. It would have to be very thin because it is wrapping around an entire star, you know? So yeah, 3 million times the surface area.
Crazy.
Yeah.
All right. These are the current scores. It is basically down to these last questions.
Yes. All right. Let's do technology for 1,000.
All right. This one is a little strange because.
All right. We can handle that, can't we?
I was struggling. I was like, what could be a $1,000 technology question? Here you go. Prove you are not in a simulation.
Prove that I am not in a simulation.
Prove that you're not in a simulation.
Well, I guess pi hasn't come to an end yet. That's the most common one, I'd say.
Is that a way you can tell that you're not in a simulation?
Well, if it were to come to an end, it would prove that you are in a simulation, but P implies Q does not mean Q implies P, so I guess not. How else? Prove that I am not in a simulation. Oh man. The difficult thing is that there's more stakes to this. If I get this wrong, it's not just getting it wrong.
Yeah.
It's existential crisis inducing. You can't,
exactly.
I guess.
That is the answer.
Okay. That's the answer.
Correct. You cannot.
Yay. You can't. Wow. That's fun.
That's literally my answer statement for that. It's just, you can't.
Oh my
god.
That's fun.
That is fun. I was like, alright, come on, we gotta make this a fun one.
Oh yeah. All right.
You answered the question correctly, but at what cost?
At what cost? I won. But at what cost?
All right, and we are on to my final question.
The habitats, or astrography. Yes. Astrography for 1000. Okay. In the early 1850s, the category of asteroid had not yet been invented. So how many official planets were there? And this is the maximum number of official planets there ever were. At one point, there were X many official planets. What is X?
All right. Mercury and Venus do not have moons. The Earth has one moon. Mars has 2 moons. Jupiter... Oh, but how many of Jupiter's were observed? In the 1850s, obviously the first 4 were observed, so that kicks us up to 7. Let's go start storing.
Well, the moons were moons. We're talking about asteroids here.
Oh, we're talking about just asteroids. Okay.
Yeah.
So this is 4 big ones. I'm willing to guess one of those 4 that we mentioned before, Ceres, Juno, Pallas, and Vespa. I'm willing to bet one of them, at least one of them, had not been found. So it's 3. So had Pluto been found? Because if it had been found, then it was definitely considered a planet. So I'm gonna say there were. And what's the tolerance on this one?
I'll give you plus or minus. Let's see. I'll give it 20%. I'm not, so I don't want to specify like how much,
Okay, yeah.
So plus or minus 20%.
Okay. To just play the odds, I'm going to say 15.
Let me see if that is within 20%. So 15 times 1.2. No, it is 23.
Jesus.
Yeah. That includes Ceres, Pallas, Juno, Vesta,
they knew all of them.
Astrea, Hebe, Iris, Chiron, and not Pluto at this point. They hadn't actually discovered Pluto, but they had other ones like, let's see. Here, wait, let me just look at.
How the hell were they in the 1850s and they knew more planets than me?
Yeah. No, yeah. It was beginning to become inconvenient. They were like, wait a minute, guys, there's too many planets. I can't remember all of these. And then, yeah.
I guess that is it, because there's no way I can...
That is it, pretty much.
But let's see.
Do you want to do the... Yeah, I'll do the last question.
But
all right.
Good game on that front.
Yeah. Thank you. You too.
All right. What was your last one? Habitats?
Yeah, habitats.
Okay. I acknowledge that this is not true. Because this is not the formula you use to get the surface area of a cylinder.
Oh, okay.
But, so this is really a ratio question.
All right.
Because even if I used the wrong equation, the ratios are still the same. Assume an O'Neill cylinder has an area of 100 square miles, which it doesn't. But assume that it does. And assume that this O'Neill cylinder could host 500,000 people aboard.
Okay.
Using the original proposition of the original design, how many people could a McKendree cylinder hold using
Okay.
the same population density as on the O'Neill cylinder.
Okay. McKendree was 1,000 miles long, but then what was its diameter? Let's say 100. So then that would be 100,000 in this 100,000 square miles. Simple. Oh, can I use a calculator?
Yes.
All right. So 500, 1, 2, 3, divided by 100 is 5,000 people per square mile. And then times... The original population was 500,000, right?
Yes.
For the O'Neill cylinder? Okay.
Yes.
So then times 100,000, 103, gives you an answer of... What is that? 500 million.
Unfortunately, that is not correct. The
That's
McKendree cylinder is actually much bigger than you gave it credit for. At least the original design of it was. The original proposal of the McKendree cylinder was a cylinder approximately 290 miles in radius and 2,900 miles in length, making it about the same living or land area as that of Russia. And that, using the same population density, would be 4.2 billion. Actually, it might be more because I didn't treat the radius like a diameter. But
interesting. You could fit a whole USSR in there.
Yeah.
Sounds like.
Yeah. And so there you go. That's the game. And Max has taken the win on this one. I believe you I don't really remember. I think I might have won the last one.
Here, I think so, yeah.
I'm gonna here, I will move
our things. It is time.
But it seems like there's been some chronological disturbances.
There has been a chronological disturbance.
Stop it! What's going on here?
What is Stop It doing here? Come with me and all shall be revealed, says Stop It.
Oh, all this time? What, could this be a glimpse into a future season? Into the next one?
Yes.
Oh no. I have a bad feeling about
this. I have a bad... Yup.
Alright,
Meanwhile, elsewhere, you have failed me for the last time. Gravity mid 49 seconds.
It can't be. He's still alive.
Silas has returned.
Still alive.
Bum.
Well,
on that note,
we go on to final thoughts.
Well, that was a fun game show. With some interesting plot developments.
That doesn't bode well for us. We thought he really destroyed the beast.
Yeah, exactly. So we'll have to deal with him in the next season of the Gravity Max live stream. Oh yeah.
But man, the season was so fun and so
That was a fun season.
It was awesome.
That was a good season.
I love that so much. But yeah, and then this was a great game show. We should get the actual tally of who has won what.
Oh yeah, we should do that. We can do that later.
I think it actually might be. It's either.
It might be 3-3 to be honest.
I think it is 3-3.
Perfectly balanced.
If it's not that, I think it's 4-2 in your favor.
Yeah, but I can't believe it's 4-2. 4-2 sounds too unbalanced to me.
I don't know. Maybe it is 3-3, and we're coming into this new season on equal footing.
Yeah. All right. So yeah, that was fun.
Next episode will be Rento, where we will be playing.
Oh yeah,
Rento to just commemorate.
Yes.
Probably, some other games. If we think about it, we might hop on Minecraft.
Yep.
We might hop on whatever. But yeah, thank you all for joining us through this journey, this trek through space, the final frontier.
Yep.
Thank you for joining us.
Thank you, everyone.
Oh, and yeah, we haven't mentioned David Bowie once this entire season.
So
we're doing it now.
We're doing it now.
Shout out to David Bowie.
Yeah, shout out to David Bowie. Very good music, like incredible.
I love it.
It's interesting. David Bowie has like released albums, I've heard, starting in the 60s and up until the 2010s. That's like 6 decades.
Yeah,
60s,
he
70s,
released
80s,
an
90s,
album
knots and 10s.
a year before he died in 2017. So,
yeah. Yep. Black Star, right?
Black Star. Yep.
Yeah. Anyway, yeah. Thank you guys all for watching, and thank you, Sebastian, for being my co-host as always this season.
As always.
Very fun. So yeah. Bye, everyone.
Bye-bye.
Bye-bye.